Hey guys, we are talking about perimeter of similar figures. Now, first of all, as we get started, if the figures are similar, then there is a rule concerning their perimeters. And here it is. If they're similar, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths. So let's write that down. So 1, if they're similar, ratio of their perimeters is equal to the ratio of corresponding side lengths. Okay, so if we have two figures, let's say two rectangles, the first one labeled A, B, C, D, this is figure number 1, and then we have a second rectangle, a little bit larger but similar to the first, W, X, Y, Z, and this is figure number 2. Then perimeter, the ratio of the perimeters, so perimeter of number 1 to perimeter 2, so you have the ratio of their perimeters, is equal to the ratio of the corresponding side lengths. So what does that mean? Let's first of all find the corresponding side length. So A and B here corresponds with WX. So that ratio, we could represent it as AB over WX. So whatever those values would be, the perimeter, that ratio of the perimeters would be equal to the same ratio of that corresponding side length. So similarly, another corresponding side length between the two figures is BC and XY. And remember, whatever value we decide to give them, whether it's 2, 3, 4, 5, or 6, whatever that ratio is, it will be the same ratio of our perimeters. And I'm just going to go ahead and indicate or label the other corresponding side lengths, okay? So here we go, CD to YZ. And notice that I am putting the side lengths for the first figure all in our numerator and the side lengths for our second figure all in the denominator. Okay, and finally DA corresponds with ZW. Okay, so let's go ahead and look at an example, maybe one or two, that will help us to better understand this. Here is example number 1. Find the ratio of the perimeters, red to blue. Well, the ratio of our perimeters, red to blue, so let's go and say perimeter of red to the perimeter of blue is equal to the ratio of the corresponding side lengths. So let's go ahead and look for corresponding side lengths of our two figures. Well, we are given values for the base of our triangles, so that will be the best option when we're trying to find corresponding side lengths. Okay, so the base of our red triangle is 3. That goes into our numerator. And the base of our blue triangle is 12. And that goes into our denominator. Notice that I'm keeping all of the values for the blue triangle in our denominator, and all of the values for the red triangle in my numerator. Okay, I'm pairing them the way they're supposed to be paired. Now, can 3 12s be simplified any further? Your answer should be yeah, it can, because there is a common factor between 3 and 12, and our common factor is 3. So this simplifies to 1/4. So 1/4 is the ratio of the perimeters red to blue. And we're done with part A. Now part B says, if the perimeter of the blue figure is 24, find the perimeter of the red figure. Now we're going to go ahead and write down information that we've already been taught, okay? We are told that the perimeter of the red to the perimeter of the blue, or the ratio of those perimeters, is equal to the ratio of the corresponding side lengths, which we just found to be 1/4. Okay? Now question, are we given any other information that will help us to solve for the perimeter of the red figure? Well, in our question, we are told that the perimeter of the blue figure is 24. So we're going to go ahead and substitute, instead of using the perimeter of the blue figure in our denominator on the left-hand side, we'll put the value that they gave us for that perimeter, which is 24. Okay? And we're solving for the perimeter of the red figure. Now, in our numerator on the left-hand side of our equal sign, instead of putting P red, or the perimeter of our red figure, we're going to represent that unknown using a variable. And the variable that is most likely or commonly used is x. Now, looking at this, does this look familiar? X over 24 equals 1/4. If it doesn't, it's okay. But this is the format that we love to see because it indicates that we can do cross multiplication. We have a fraction equivalent to another fraction. So cross multiplication says that the product of our diagonals are equal. So we have the product of the first diagonal, which is 24 times 1. So 24 times 1 is equal to the product of our second diagonal, x times 4, which is simply 4x. Okay, 24 times 1 is just 24, equal to 4x. Now remember, we're solving for x. X is our perimeter of the red triangle, so we need to get that by itself. And you're going to go ahead, in order to do that, get rid of the 4 because it's in the way. And the operation between the 4 and the x is multiplication. And so we do the opposite, which is divide by that thing we're trying to get rid of, which is 4. Whatever we do on one side of our equation, we must do on the other side to keep that relationship true. Okay, so now we're left with 24 divided by 4 is 6, and that is equal to x, okay? Because 4 divided by 4, or 4x divided by 4, is simply 1x. Now 6 equals x is the same as saying x is equal to 6. So here we have the perimeter of our red figure is 6. Let's take a look at another example. In our second and final example, we have here two parallelograms, and we are told to find the ratio of the perimeter. Now, I will encourage you, go ahead and try this one yourself. Pause the video and press play when you're ready. Now, let's solve. The perimeter of our similar figures, the ratio, so the ratio of the perimeter of the blue to the perimeter of the red is equal to the ratio of our corresponding sides. Now the corresponding sides that we've been given, blue to red, remember blue is first, so it's going to be in our numerator, 6 to red, which is 72. So we have 6 to 72. This can be simplified because of a common factor, which is 6 to 1 over 12. So this is the ratio of our perimeters, blue to red. Part B, if the perimeter of the blue figure is 100, find the perimeter of the red figure. So the perimeter of the blue figure is 100. And we don't know the perimeter of the red figure, so we're going to replace P of R, or the perimeter of R, with the variable x. And we know that that is equal to the ratio of the corresponding side lengths, which we have discovered is 1/12. Now we have it in a format that we are familiar with, and we're going to cross multiply. The product of our diagonals are equal. So our first diagonal is going to be x is equal to 100 times 12, which is simply going to be x is equal to 1200.